Well, I said in the previous video that these are three special angles. Well, a legitimate question is, well, what makes them so special? Why not 20 degrees and 80? Why not 20 and 80 instead of 30 and 60? Well, the reason 30 and 60 are particularly special is because they come from the special equilateral triangle. 20 and 80 don't come from that triangle. 30 and 60 do. What makes 45 so special? Why isn't it 40 and 50? Well, because 40 and 50 don't arise from a square. 45 arises from a square. Because of their origins and because of the complexity that goes on in that process, it turns out that these particular angles have particular properties that make them particularly useful in the work we're going to be doing. And so, we're going to take a look at the function values of these triangles. Now, step one, we're going to find sine of all three angles. Once you have sine of all three angles, it turns out you can get everything else. If you know sine of these three angles, you are in like Flynn because everything is good to go. If you know sine of those three angles, and you know the other properties, we know that cofunctions of complements are equal. Cosine is the cofunction of sine. So if you know sine, then you know cosine of the complements. And notice, these are complements of each other. This is a complement of itself. If you know sine, then you get cosine because cosine is a cofunction. If you know cosine and if you know sine, then you get then you get tangent. Because if you know tangent is sine divided by cosine. Remember our x, y, r definitions? And so if you know sine and cosine, then you get tangent for free. You don't need to memorize anything new. Tangent is sine over cosine. All you need to know is sine. From sine, you can generate cosine. From cosine, you can generate sine and cosine, you can generate tangent. And if you know sine, cosine, and tangent, then all you need to do to find cosecant, secant, and cosecant, or cotangent, is to form the reciprocals. If you know these three, then trigonometry doesn't become a memorized contest. It becomes, I know information, I know how to produce the new information, and so I have that information at my mind's disposal because I am familiar with the basic principles of trigonometry, and you must know these values: sine of 30 degrees, sine of 45 degrees, and sine of 60 degrees. Those are just bedrock. Okay, so let's see if we can put this together. Okay? If we have a 30, 60, 90 triangle, 30, 60, 90 triangle, remember what the values were. Remember, this is 2, this is 1, this is square root of 3. And all we need to know is SOHCAHTOA. What is sine of 30 degrees? Sine of 30 degrees, sine, SOHCAHTOA. Sine is opposite over hypotenuse. So sine of 30 degrees is SOHCAHTOA. Let's write it this way. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. So we know sine of 30 degrees, it's always the same. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. You can always use 30-degree angle. Now, a question might arise, what if you use a bigger triangle? Suppose this is 2, this is 1, this is theta. What if you use a bigger triangle? Right? Now this is 1. What if this is 3 and this is 6? It doesn't matter. They're similar triangles. It doesn't matter how far out this angle you go. These are similar triangles. We've already talked about that. So it doesn't matter what similar triangle you use. Sine is opposite over hypotenuse. So sine in this small triangle, sine is 1 over 2, 1/2. In the large triangle, sine of theta is opposite over hypotenuse. That's 3 over 6. But that's still 1/2. It doesn't matter what triangle you use. So you could go out here and do this as 8 and this is 4. But sine is still 4 over 8, opposite over hypotenuse. That's still 1/2. They all work. So you might as well pick the simplest. This is the simplest of the pictures. This is the simplest picture. In fact, here's how important this is. If I were to ask you in this course to draw a rough sketch of the basic shape parabola, it doesn't have to be fancy, it doesn't have to be all detailed in. If I ask you to draw the basic shape y equals x squared function, just the basic y equals x squared function, I would fully expect you, and you would fully expect yourself, to be able to draw that sketch very approximately, very quickly. This picture is in your mind's eye. You have it nestled in your mind because you know what the basic shape parabola looks like. If I asked you to draw the basic shape parabola, I would expect you to have zero difficulty getting a rough sketch of the basic shape parabola. In exactly a similar fashion, in an exactly same fashion, if I ask you to draw a 30, 60, 90 triangle, draw and label 30, 60, 90 triangle, I would expect you, and you should expect yourself, I would expect you to be able to put this picture, this is 2, this is 1, this is square root of 3, this is 30 degrees, this is 60 degrees. I would expect that picture, in fact we don't even need this, I would expect this picture to become, you should be able to get this picture easily. 30 degrees, 60 degrees. This is 1, this is 2, this is square root 3. All right, so what is the basic? If I ask you to draw a picture of the basic 30, 60, 90 triangle, what is the basic 30, 60, 90 triangle? This is the basic 30, 60, 90 triangle. This is 2, this is 1, this is square root of 3. That is the basic 30, 60, 90 triangle. That should be automatic. You should visualize it in your mind's eye in one-tenth of the time it takes to draw this. It takes 10 times longer to draw this than it does to visualize it in your mind's eye. Again, can you draw a picture of the basic 30, 60, 90 triangle? Here we go. There's 30, there's 60, there's 90. This is 2, this is 1, that's square root of 3. The triangle has been drawn. You now have that triangle at your disposal. You should be able to visualize it in your mind's eye just as easily as you can draw it out there. In fact, you should be able to visualize it in your mind's eye immediately. If you do this, then trigonometry will not become a memorized contest. The other ways, there are some instructors that teach it this way, and God bless them, that's fantastic. But if you don't learn this, then trigonometry is going to become a memorized contest. Because if you know this, this is easy. If you know this is easy. And we're going to have another triangle, then this is going to be easy. Then these things become easy, which means you have all the trigonometric functions. You have all 6 trig function values for all 3 angles. 3 angles, 6 functions, that's 18 different pieces of information. If you can draw this picture, you don't need to memorize any of them. You don't even memorize these. Because if you have this picture, you can compute these. If you have this picture, you have all of them. This one and the other triangle we're going to draw. If you have these triangles in your mind and you can draw them down quickly, then you have 18 pieces of information at your disposal. If you don't want to do that, that's wonderful. But then you need to memorize 18 different pieces of information. And so my recommendation, to this day, this is how I do it. To this day, this is the way I learned it way back in 1937. And I'm not saying it's the best way in the world, but it's the way I learn it. I think it's a convenient way for you to know. And the nice thing is, you don't have to memorize stuff, which means you won't forget it. Drawing a picture, you almost never forget how to draw a picture. But you might forget details of information. All right, so here we go. So there's my 30, 60, 90 triangle. Now, how does this help? 30, 60, 90. What is sine? What is sine? Sine of 30 degrees. So from this perspective, sine is opposite over hypotenuse. Sine of 30 degrees is 1/2. 60 we get from this perspective. Let's change our perspective. From this perspective, sine is opposite over hypotenuse. Sine is opposite over hypotenuse. So sine of 60 is square root of 3 over 2. Now 45 degrees comes from the other triangle. This is 1, this is 1. This is 45, 45. The question is, how much is that? Well, Pythagoras tells us that. Pythagoras tells us this length of this side. Let's call this x. So I know 1 squared plus 1 squared is equal to x squared, which gives me 1 plus 1 is equal to x squared. 2 is equal to x squared. So x is positive or negative square root of 2, but we're doing distance. We're not doing a coordinate system, so we're not going to use a negative value. So we have x is equal to the square root of 2. So you should be able to draw that picture. You should be able to draw that picture and that picture just as quickly as you can draw a picture of the absolute value function. Every one of you should know in your mind's eye the picture of the absolute value function. Every one of you should know in your mind's eye by now the picture of the basic shape square function. You have those basic pictures in your mind's eye. I mean, you have all kinds of shapes in your mind's eye. In your mind's eye right now, look at, do you see a stop sign? Look in your mind's eye, you see a stop sign. That's how quickly you should be able to visualize the 30, 60, 90, and the 45, 45, 90 triangle. And now, it doesn't matter from which angle you take the perspective, because 45 is the same for either of them. So just pick this one. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. So that is 1 over the square root of 2, and you don't need to simplify that. So what we have, I'll write this in a little bit more clear fashion here. We have sine of 30 degrees is 1/2. Sine from 30 degrees is opposite over hypotenuse. Sine of 45 degrees. Sine is opposite over hypotenuse. That's 1 over the square root of 2. Now, remember, if you want to check your answer with a textbook, textbooks will not leave your answer like this. Textbook will change this into square root of 2 over 2. So we will assume, I will assume that if you see this and the answer has this, that you know those are the same thing. If you see this and the answer has this, I will assume you know those are the same thing. Right? You multiply top numerator and denominator by the square root of 2. You rationalize the denominator. And then sine of 60 degrees. Sine of 60 degrees. 60. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. That's the square root of 3 over 2. So those values, you should be able to, as soon as you draw this picture, you should have those values. You want cosine? You don't need any rules. They were smacking you right in the face. You want cosine of, let's say, 60 degrees. What's cosine of 60? From the perspective of 60, cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. What is tangent of 45 degrees? Tangent is opposite over adjacent. What is secant? What is secant of 30 degrees? Secant of 30 degrees? Secant is hypotenuse over adjacent, because it's a reciprocal of cosine. Secant is hypotenuse over adjacent. So secant of 30 degrees is hypotenuse over adjacent. That's 2 over the square root of 3. You have all 6 function values for all 3 angles just because you know what these 2 triangles look like. If you can draw those triangles, you are in. You don't need any other information present. You don't even need a calculator, because you can have these exact values. Now, if I ask you for sine of 45 degrees, if I ask you for sine of 45 degrees, not if, when, when I ask you for sine of 45 degrees, and when I ask you for exact value, sine of 45 degrees, exact value. If you give me 0.70710678, That is not it. That's not correct. That's not accurate. That's not what I asked for. That's not what you're giving me. That's not. I do not want the decimal value. If I ask you for sine of 45 degrees, you give me either 1 over radical 2 or radical 2 over 2. I don't care which of those you pick. A sine of 45 degrees is one of those two. If I ask you for cosine of 30 degrees, cosine of 30 degrees, from 30 degrees, cosine is adjacent over hypotenuse. So that's square root of 3 over 2. If you give me the decimal value, which is 0.866025 blah blah blah, then you're not getting any credit out of me because you didn't answer what you were asked. The question is, what is the exact value of cosine of 30 degrees? The exact value of cosine of 30 degrees is square root of 3 over 2. Because cosine is adjacent over hypotenuse. So you need to have these triangles in your mind's eye. That needs to be part of your mental furniture. I have some techniques I can use to try to force you to learn those. But you need to be able to draw this out at a moment's notice. At the drop of a hat, draw out these triangles. Eventually, you don't need to draw them. They're in your mind's eye. And so then you begin to visualize. So if I say visualize the 45, 45, 90 triangle, boom, I got it right there. It's right there. And so then what is cotangent? Cotangent is 1 because I got it from the triangle. The point is not speed. The point is accuracy. And if you have these triangles in your mind's eye, you have perfect accuracy. You can find any one of those function values for any one of those special triangles. And then we're going to generate more ways to know even more values if you know the basic triangles.